Hello and welcome. My name is Paul Brett. I am a Senior Software Support Analyst for the Transformation Extender product from IBM. Today's video is an overview of the capabilities of the Data Transformation Engine at the core of ITX. Please follow me on Twitter at PaulBrettIBM. Consider the data stream on screen. This could be from any source for which ITX has an adapter, and there are many. We have 4 distinct items, each terminated with a new line byte sequence. Paul, Brett, operations, and a date of birth. The data stream is read into a type tree. Consider the type tree as a bucket. Now this bucket can hold further buckets. Here we have defined 4. And we've set the properties so that the validation engine knows that each is full when the new line byte sequence is encountered. As the data stream is read, each of the buckets is populated with data. This continues until the data stream is exhausted. Here is my output type tree. It is simply another bucket. The main bucket has some properties defined, called an initiator and a terminator. It also has 4 sub-buckets, also with properties. Don't worry too much about this type tree, as it can be easily created with an importer. Now we get to the actual mapping. You can see my input type tree on the left, complete with data in buckets. You can also see my output on the right, currently empty. In this simple mapping, the 4 data objects are copied from the input structure to the output structure. And mapping is complete. Here you see the result of the map. The data on the left has been transformed from the simple format into the XML format that you see on the right. Now, this is just the data stream. The output adapter then takes this to the target system, be that a file, an MQ message, an email, or something else. As I said before, ITX contains a lot of adapters. Moving on to a more complicated example now. Here is the type tree for a database query result. It is basically 0 to many rows, terminated with a new line byte sequence at the end of each row. Each row has 4 fields, separated with commas. As you can see, I have represented this as buckets, and as the validation of the data proceeds, you can see the data stream slowly fills the buckets. Here we are at the mapping. Our inputs shown on the left, a stream of data parsed into the buckets, the main one of which contains 0 or more row buckets. We need to drop to a functional map, and as the argument to the functional map call in the rule, we send in 1 row. Down at the functional map level, we then only have 1 row to map on both input and output. Mapping is easy. The data is returned to the executable map, the top level. When the mapping is complete, after the executable map has called the functional map x times, x being the number of rows, you're left with the completed output as shown here. As you can see, I've kind of cheated and only done 4 rows, but you can see the general concept. In summary then, I find it helps to think of type tree objects as buckets. On input, these buckets are populated when a map parses the input data stream and is the same regardless of the source, which is determined by the adapter used. It is worth noting at this point that the content of the bucket may not match the raw data stream exactly. For example, when an XML stream includes the AND AMP semicolon sequence to represent an ampersand, the bucket will hold the ampersand only, as the escape sequence is normalized. The opposite is true on output. An AND sequence may be escaped, and the raw data stream on output would contain AND AMP semicolon again. I appreciate you taking the time to view my video today. If you found the content enjoyable, please click the like button. You can also subscribe to my channel and click the notification bell to be informed of new content. Thank you. Have a great day.